here, dividend yields, okay, give a symbol minus Q or Q. Okay, that's the dividend yields in percentage. Alright? So the futures price and stock price relation, we just adjusted these dividend yields. Remember, yeah, Q is an income, right? From holding the spot position. So that's why it's a deduction from your pricing model. Okay? So when Q is the dividend yields on the portfolio represented by index during the life of the contracts. So remember, yeah, that's in percentage. So if dividend is in dollar amount, I, so remember F0 equals to S0 minus I, that's the present value of a dividend, and then over times e to the power minus, RT, not minus, okay, e to the power RT. Okay, so I representing the PV of dividend income in dollar amount. Okay. For the formula to be true, it is important that the index representing an index asset. Okay, so that means the index equals to local currency. As I just mentioned that if this index is representing with different currencies, will be incur the currency risk, so your formula may not be valid, okay? Only other word changes in the index must be corresponding to the value of a tradable portfolio, okay? So very important is same currency, okay? So in the textbook, for instance, Nikkei index viewed as dollar amount, it could be possible, okay? Because that, for instance, TSMC has the ADR traded in US dollar in New York Stock Exchange, right? So obviously TSMC underlying share is quoted in Taiwanese dollar, and then TSMC ADR is quoted in the US dollar, okay? So in that case that if you use this formula, sometimes you don't find the equivalency, okay? The reason is there is a movement in the exchange rates, okay? So Nikkei index, if they have a futures available in the US, because Nikkei index is in Japanese dollar, right? Okay? If they are traded in the dollar, then in that case it's not exactly investment asset, okay? Because foreign exchange risk may arise, okay? And this will actually, brings the differences in the equilibriums, okay? You would have a gain and losses in different currency, right? So let's continue. Check out this question. A stock index currently at 330. That's in points, okay? So S0. The risk-free rate is 8% per annum, that's R. And the dividend yields is 4%, that's the Q, okay? So what should be the future price for the 4 months contract be? Remember, T would equals to 4 months divided by 12 months, okay? So that's the basically the condition. And then if we put up the formula, F0 equals to S0E, that's in percentage, right? So it's R minus QT. So S0 is 350 points times E to the power of R is 0.08 minus Q is 0.04 and T is 4 months minus over 12 months. So 1/3 basically, okay? So you can figure out the forward price for the index is 354.7. In the exam, let me emphasize again, most of the question I will put the continuous form like this, okay? If you don't use the industrial engineering computation or computer calculator. And then in that case, what I'm doing is I will offer you a table with a lot of number for exponential. So you choose the appropriate one. For instance, that here you should choose e to the power 0.04 times 1/3. So I will provide this number there with the correct number. So you just pick up the number to do your computation. Can you guys follow me? Okay, but you still have to select the correct one. Okay, if you choose the wrong one, you will actually end up with the wrong number, right? Okay. So I provide you a table of exponential terms. Don't worry about that. Right? Let's continue. So the risk-free interest is 7% per annum. So that's the RF. And the dividend yield on the start is 3.2. That's the Q. Current value, that's the S0. Okay, 6 months, that's a T. 6 months over 12 months. So T is 0.5. 12 months. Okay, so basically you put up the formula F0 equals to S0 E. Q is in percentage, right? So basically R minus Q T. Okay, so R is 7%, and then Q is 3.2%, T is 0.5. Okay, so you figure out it's 152.88. That's the formula. Okay. All right, so if we are able to price the model value, then in that case, you are able to use the model value to precede your arbitrage strategy, right? So obviously that we learned that already. When F0 is higher than S0 ER minus QT, remember, that's your model price, right? And that's your market price, agree? This formula is for us to compute the model price, right? So when the market price is higher than the model price, arbitrager will buy low, sell high. So remember, yeah, you cannot buy the model, so you will buy S0, which drives your price too low, agree? Okay, so you will write down the principle, buy low, sell high. And then you will buy the spot, and then you sell the futures. Okay, on the other hand, when the market is lower than the model, then you buy the futures, and then you sell S0. Don't forget, you are not selling the theoretical model, you sell the S0. Okay, that's our arbitrage principle. So far so good, yeah? Okay. So, index arbitrage. Okay, so when we talked about arbitrage, Tao Li, remember, yeah? We say that the principle was buy low, sell high, but when you execute this strategy, you do it in the same time, right? Okay, so that's why in the same time means simultaneous, means the same time. Otherwise, it's not arbitrage, okay? Because price in different time can be different, right? Okay, trades in the futures and many different stocks, okay? Very often, we cannot do that manually, okay? So basically, computer will help you to distinguish the arbitrage opportunity and to execute the strategies, okay? In order to generate arbitrage profit. Occasionally, simultaneous trade are not possible and theoretical non-pricing arbitrage relation does not hold, okay? So that's the reason when there is an extreme market. especially like a market crash. Okay, so in that case, only buy calls or sell calls. No deal done. When everybody's standing at the long position or everybody's standing at the short position, it's very difficult to execute arbitrage, okay? Because you have to buy one, sell another, right? So, for instance, that both the futures market and the spot market, they are both going down, you cannot do that, okay? So, when there's a liquidity issues, you cannot execute this opportunity, okay? For instance, that it's appearing a few times already, right? Like in COVID-19, in March 2021 and 2020, okay? There are a few times there's the market distinguished, okay? So in that case, when there's a break in the market, it's very difficult to execute the arbitrage opportunity, okay? 1987, okay, in October, this is what we call Black Monday. That's also the day the US market have a crash, okay, collapse in the market. So in that case, everybody going to sell, nobody standing at the high position. In that case, difficult to execute the arbitrage, okay, strategies. That's the thing, okay. So remember, yeah, arbitrage trading is on the condition whereby liquidity is high enough, okay. So allows us to execute both buy or sell high in the same time, all right. Take a look at this question. Suppose that risk-free rate is 10%, that's the R0, RF, okay? And then continuous compounding, that the dividend yield is 4%, that's the Q. Index standing at 400, that's the S0, okay? And here it gives you the market value, okay? Market value for 4 months, that's the T equals to 4 months over 12 months. And then that's the F market. Okay, question asks us whether or not there is an arbitrage opportunity. Okay, so first of all, this time there is dividend involved, right? E to the power of R minus QT equals to 400 times E to the power of R is 10% minus Q 0.04. This is 0.1. 10% is 0.1. Okay? And then to the power of 4 over 10. Okay? So you figure out the theoretical value is 408.08. Remember, that's the model price. Okay? And then the market price, F0 model equals to 408.08 is higher than F market, which is 405. Okay, so what you do is to buy futures and sell. You cannot sell the model, so sell S0, right? Okay? So I think we are pretty familiar with this. Yeah?
Oh, Professor, what is the time 4 over 10, not 4 over 12?
Because here it says 4 months.
Or why is over 10, not 12?
Oh, where did I put it? Oh, sorry. Thank you. Turning me here, right?
It is.
Thank you. 4 over 12. Yeah? Alright, okay, next slide, the same thing, okay, so you can just refer to this, okay, so eventually conclude buy futures contract and short the shares, okay, underlying the index. So you buy F market, you sell S0. Okay, if that's alright, I'll continue, yeah? Now, this one special, because currency futures and forward pricing is always a little bit complicated. And then from the non-arbitrage opportunity theory, okay, non-arbitrage opportunity theories, if you have a $1,000, the amount of money that you save in the US and they convert it back to Taiwanese dollar should be the same as you save in the Taiwanese dollar now, and later on the interest rate you get the same. Okay. Did you learn this in the international financial management? Coming from the theory of international Fisher effects. Okay, so put it simple way. Basically, if you have the same amount of money, okay, the money that you earn by saving in domestic country is the interest rate, right? And then the money that you earn in the foreign country is the interest rate plus the exchange rate profits, okay? And then they should be equivalent if there's no arbitrage opportunity, okay? So these equivalent relations will bring in the relation when we're trying to price the currency futures or currency forward, okay? But because that in the foreign exchange market, the quotation of exchange rates normally is a direct quotation, okay? So that means we learn the direct quotation, right? E exchange rate equals to the amount of amount of foreign currency over home currency. This is expressed in numerical term, okay? So this quotation means 1 unit of foreign currency in exchange for how many units of home currency. Can you guys follow me? This is what we call direct quotation, 直接报价. Okay, so in the pricing model of the currency relation or currency forward and futures, we are assuming that the exchange rate is following the direct quotation. So we started with 1,000 unit of foreign currency instead of home currency. Are we okay? Because 1,000, like for instance, 1,000 US dollar, like our home currency is NTD, okay? And then our foreign currency is USD, right? So following the direct quotation, E equals to USD over NTD equals to, today is something like 32.5, right? And then that means 1 USD in exchange for 32.5 NTD. Can you guys follow me? Okay, so this is what we call direct quotation. Right? So when we want to express the convert it, the foreign currency back to the home currency, this is our home, right? So basically you are using like, assuming 1,000 USD, you want to convert back to several amount of NTD. How do you do that? 1,000 USD times up exchange rate, right? USD to NTD. So this curls up, right? So it becomes a certain amount of NTD. So what you do is 1,000 USD times here is 32.5, right? And that's the USD to NTD, curls up. So that's the answer, right? That's the NTD. You guys follow me, right? So in these theories, the pricing model, we following the direct quotation here. Okay, this is the direct quotation. So in that case, we were started 1,000 units of foreign currency, okay? So far so good? Okay, so like imagine that today you are offered 1,000 US dollar, and then you have two choices. First choice is to convert this 1,000 US dollar back to Taiwanese dollar today, right? and then you can save in the Taiwanese bank for 1 year. Okay. Second choice is that you keep it as US dollar 1,000 and you save in the US bank. Then you will earn the US interest rate, right? After 1 year, you convert it back to Taiwanese dollar with the forward or future exchange rate. We agree with that? Okay, so assuming that if there is no arbitrage opportunity, you should earn the same money. You guys follow me? Okay, so this is how we try to come up with this formula here, which representing the foreign exchange rate currency futures pricing. Okay, so foreign currency is analogous to security provided yields. Okay, very similar. Okay, so that means that if you save at home, you get R, right? If you save at foreign, you get IF. F stands for foreign, not big, free. Okay? R is the interest rate at domestic country. RF is the interest rate in the foreign country. Are we okay with that? Yeah? Okay. So the yield is the foreign risk-free interest rate. That's the RF. Okay? So it follows that if RF is the foreign risk-free interest rate, F0 equals to S0, E R minus IFT. Okay, I'm gonna show you why. Okay, now, so let's take a look at the diagrams in the next 2 slides. We'll come back to the question later. Take a look at this one, okay? So, as we said, in this pricing model, we're assuming that the exchange rate is a direct quotation. So, in order to convert it back into the home currency easier, okay, we assume that we started, that's T equals to 0 today, okay, with 1,000 units of foreign currency. Okay, now you have a 2 choice. One, save in home bank for 1 year. Okay, second is in the left hand side, save in foreign bank for 1 year. So far so good? Okay, now if you want to save in the home bank, the price that you get today is a foreign currency, right? So we are assuming we are using the direct quotation. Your S0 equals to EH over F. S0 is your exchange rate. Are we okay with that? S0 here is your exchange rate. Converted, basically in this case, S0 is 32.5. Can you guys follow me? Yeah? Okay, so first of all, because you started with 1,000 foreign units, you want to convert it back, okay, to home currency. So the first step is converted foreign currency to home currency. Remember, that's today. Okay, so the amount of money that you get today, like what we write there, would be equals to 1,000 F times S is H over F, right? Cross up. So basically it's 1,000 times S0. That's in home, right? 1,000 times 32.5. So equals to 32,500 Taiwanese dollar. That's at home currency. Are we okay with that? Okay. Now, at time T, after 1 year, that's assuming 1 year, okay? So when you put your money into the bank to save for 1 year, how much do you get? 1,000 S0. You already converted to home, right? Times F, times R, okay, to the power of T, right? Because the interest rate is R, home savings interest rate, okay? T. That's your total income at T, and then remember that's already in home currency. Okay? So here, be careful, yeah? R is the interest rate for home. Okay? And RF is the risk-free rate for foreign. Okay, so the second choice, you don't convert today, you save in the foreign bank, okay? Because we started with the foreign currency, so now you don't have to convert it for today, you just directly save in the bank, okay? So save at foreign bank. Basically, you will get 1,000 ERFT. Remember, RF is the foreign risk-free rate. Okay, but 1,000 ERFT, that's in foreign currency. Agree? 是不是还是美金？对不对？ So if you want to compare, you have to convert it back to the home currency at the end, right? So convert back to home at the time T after 1 year, right? So after 1 year, you would have a 1,000 ERFT times, how do you convert it back? You are using the 1 year latest exchange rate, right? So F0, if you sending it today, you are using the future 1 year exchange rate to convert it, to see whether or not they should not have the arbitrage opportunity, right? So very importantly, take a look up here. If there is no arbitrage opportunity, $1,000 F0 ERFT should equals to 1,000 S0 ERT. Agree? Cross out the 1,000. So F0 ERFT would equals to S0 ERT. Now, our purpose is to figure out the pricing model for F0, right? So F0 would equals to S0E, remember, just bring the F to the right hand side, right? In brackets, R minus RFT. That's the pricing model, right? That's the end, okay? So, remember, yeah? If there is no arbitrage opportunity, means they should be equilibrium, right? Cross out 1,000, F0 ERFT equals to S0 ERT. And then just shift the RF to the right hand side, so equals to R minus RFT, okay? And then remember, yeah, in this formula, your exchange rate is a direct quotation, okay? E equals to E, 1 unit of F to how much unit of home dollar. Are we okay with that? Yeah? Okay, so that's why we have the formula here. Okay, so here, write down, R is the home risk-free, RF is the foreign risk-free, and then exchange rate is for foreign to home, which is the direct quotation. So far so good, yeah? Okay. If we're okay, let's take a look at this example here. Where's my example? Here? Okay. So now, a 2 months interest rate in Switzerland and United States is 2% and 5% per annum. Okay, so first of all, from here we know the T, right? Right? But we don't know which country is the home country yet. How can you distinguish? You distinguish from the exchange rate. Okay? Are we okay with that? Assuming the exchange rate is a direct quotation, so you know which one is home, which one is foreign. Alright? So take a look at the exchange rate. So the spot price for Swiss franc is 0.8 US dollar. What does it mean? That's the most important thing here. This means E Swiss franc in terms of the USD is 0.8, right? 1 Swiss franc can exchange for 0.8 US dollar. Can you guys follow me? So Swiss franc is at the bottom, right? If you express in the direct quotation, that's EF home. So which one is the home currency? US dollar. You guys follow me? Okay, so now go back to the first sentence. Interest rate in Switzerland and United States, 2 and 3 respectively. The first one is Swiss, right? So that's the RF. The second one is home, that's the R. Okay? That's the most important thing. That's the Swiss. And that's the USD. Can you guys follow me? Okay, so very importantly in this formula, if you want to distinguish the difference between the home and foreign, you look at the exchange rate. Okay, should be the direct quotation. Alright. So now that's the spot price. So write down that's the S0. Okay. The futures price for the contract deliverable in 2 months, that's F0. Okay, what is the arbitrage opportunity does it create? Okay, so now from the formula, remember, yeah, this F0 here is the market quotation. That's the market. So again, we want to compute the theoretical F0 first. Okay, so T equals to 2 months over 12 months. Okay, S0 equals to 0.8 triple 0, basically 0.8. Okay, and then RF equals 2%, R equals to 5%. Okay, write down the formula. F model equals to S0 E R minus RF T, right? We just figure out. So equals to 0.8 times e to the power of 5% minus 2% times 2 over 12, right? So you figure out the model price is 0.8040. That's the model. So now the question wants us to distinguish the arbitrage opportunity, right? So F model equals to 0.8040. And then it's lower, remember that's the current market quotation. Then FMKT equals to 0.8100. So what do we do? Buy low, sell high, right? So we buy S0, sell F market. That's our arbitrage, okay? You guys follow me? Okay, so this is a little bit tricky. The most important thing is that how you distinguish the home and foreign currency. Okay, you distinguish from the quotation of the exchange rate. All right. This is the key thing. Okay, the bottom one is the foreign country. The top one is the home country. So far so good. Yeah. Okay, if that's okay, I'll continue. Yeah. That's the answer. You can take a look. Okay. Finally, we go to the consumption asset. Actually, at the beginning, I've already mentioned about this. Okay, consumption asset because the hedging position has less negotiation power. Okay, so basically is lower or equal, right? And then secondly, when you have storage cost, can you write down this is a cost? Okay, like transportation, like the store, okay, or you have to try to keep them with different equipment, okay? In that case, it will incur some cost, okay? So when there is the cost, it's a positive in your pricing model, right? Okay, and then basically, this will be plus U when U is in percentage, okay? Will be plus U when U is in dollar amount, okay? So can you write down U is the cost incurred when hold spot. Okay? So basically your futures or forward will become more expensive. Okay. Just in case you forget everything, the key points is in this slide. This slide, okay? But the next slide is important. I haven't write it there. It's about a whole cost of a carry, okay? So let's take a look. This is the cost of a carry. 持有成本理论, okay? So if you want to summarize, okay, maybe when you hold a spot position, you can have some income and it will also incur some cost, right? Okay, so basically the overall cost of a carry will give a symbol C. Okay, C would then equals to your original risk-free rate, R, right? And then minus if there's any income, Q, right? And then plus if there's any storage cost, U. Agree? Okay, so basically that's your total interest. This is the risk-free, and that's the income, and that's the cost. Agree? That's what we say cost of a carry. Right? If they are all in percentage. Okay. If they are in dollar amount, C would equals to S0 minus I plus U, right? Present value. If they are all in dollar amount. Are we okay so far? Yeah? So basically, for the investment asset, you can summarize your income and cost, right? For the investment asset, it will be S0e to the power of CT, so it's S0e to the power of R minus U plus Q, T. Okay, and this is F0 lower O equals to S0 E R minus Q plus UT for the consumption, because consumption is lower or equal, right? We went through this already. So far so good? Okay, so that C is what we call cost of a carry. When you carry the spot position, all the income and cost incurred in this position. Are we okay with that? Okay, now finally, there's an extra variable, okay, that could adjust the pricing for cost of the carry, and that variable is a Y. Can you write it here? What we call convenience yield, 这个叫便利性收益。Okay, convenience yields has a definition very special. Actual profit, the spot position could earn from refining the underlying. So what does it mean? The most typical examples, actually, it could create a spread strategies, okay? But here we don't go into too detail, but I want to give you two examples, okay? One is from crude oil, 原油, okay? You can refine to heating oil. Okay, which one is more expensive? Crude oil or heating oil? Heating, right? So if you are able to refine your spot position from crude to heating, it can bring you more income, right? And more income will serve as a deduction in your pricing model, agree? So it's a negative. Can you guys follow me? It's negative because, for instance, that before we say you're holding a spot and then you have a dividend, so the future price goes down, right? Now you're holding a spot, originally is a rough product like a crude oil. You refine it to heating, so it brings you more income. So it's a deduction, right? Future price will even go down. Because remember, crude oil futures cannot refine, right? It's just a financial term. But the crude oil spot can refine, becomes other more valuable products. Are we okay with that? Okay. This is what we call crack spread. 裂解式价差, okay? Crack. The second one, yellow beans. The original raw ingredient of yellow beans can be refined. 黄豆可以变什么？豆花。像跟我外国人讲的吗 ？Tony， 你也知道豆花哦，你不是印尼人。Okay, yellow beans can press into oil, right, and powder, two products, so more valuable, right? So yellow bean oil. Oil, okay, and yellow bean powder becomes two products. So obviously it will be more valuable compared with the original ingredient, yellow bean only, right? Okay, so this is what we call crush spread. Okay? So these two typical examples basically is to tell you if you are having some spot position, especially for the consumption asset, okay, you are able to refine your original raw ingredient into more valuable products, But yellow bean futures you cannot, right? It's just a futures, okay? So it will further bring down the price of your futures or forward products, contracts. Are we okay with that? Yeah? Okay. This is what we call convenience yields. Okay. Now, finally, your full pricing model can be F0 equals to S0 e to the power of a cos of a carry minus YT, right? And then if you expanded that, F0 equals to S0 e, then here would be R minus Q plus U minus YT. That's the full model. Okay? So far so good? Yeah? Okay, tell you, yeah, this really exists in the futures market, okay? Because in the futures market, you could have a crude oil contract, you could have a heating oil contract, okay? So if there's price difference in parity between this contract, then you have the opportunity to create a spread strategies, okay? All right, so finally, we're gonna wrap up to go back to the original pricing model. Okay. Now, in the original pricing model, F0 equals to S0 E R F T, right? That RF over R is the risk-free rate. Agree? Okay. Now, if this underlying is more risky, that case you might have different expectation, right? So another formula, EST, that's the expected value of this spot price in the future, okay, would equals to S0 EKT. So S0 is EST, then E minus KT, right? You can do that, agree? So in that case, F0 E minus RT would equals to EST E minus KT. Agree? And finally, F0 equals to EST E R minus KT. Do you see? This formula equals to here. Are we okay with that? So far so good. Okay, now, finally, why do we come up with this formula? We want to tell you this table, okay? When your portfolio has different risk level, sometimes it will drive the differences between the K and RF, and in the end, the price of F0 and expected value will be different as well, okay? So let's write down our final formula here. F0 equals to EST times e to the power of R minus KT, right? We just come up with that. So when there is no systematic risk, your required rate of return would equals to the RF, right? Because there's no risk. So your return would equals to risk-free rate. Agree? Okay? So therefore, when R equals to K, when R equals to K, here is 1, right? E to the power of 0t. E 的零次方是1哦，对吧？你们知道吧？好 so here is 1, F0 equals to EST. Agree? Okay. When your portfolio is more risky, you have a positive systematic risk. Your required rate of return is higher than risk-free rate. So R minus K is negative, right? So it will drive the F0 become lower. Agree? Then EST. Are we okay with that? Okay. So basically, when you take a higher risk, you would have a higher expected price. Right? Finally, when you have negative systematic risk, obviously that's rare, okay? Because the risk-free rate is also only R is already lowest level. However, numerically, we can express this term, okay? So when there is a negative systematic risk, required rate of return even lower than R, So when you put here, it becomes positive, right? So your F0 will be higher than ESD. Are we okay with that? Yeah? Okay. So this is how in the pricing model, when your underlying have different level of risk, you can refer to here to adjust your required rate of return and expected value in the future. So far so good? Yeah? Okay. So I think that's it for, I didn't know the time's up for today. Before you go away, next week, this one, trading strategy, okay? And then this one, the tutorial. I'll go through tutorial first and then trading strategies. And then there's a tutorial on trading strategy as well, right? If you can